Over the past 4 years, exercising environmental asset protection, we learned yet again that to do law enforcement, you need situational awareness. The WAS system provides situational awareness in terms of in-time intelligence and gives you the initiative that you need. And in the layered perimeter protection concept that we follow, the system plays an invaluable role.
We were approached by sandparks to investigate how one can use radar and other sensors to do wide area surveillance. The focus of the system is to do persistent surveillance over a wide area that can give us area coverage so that we can see people walking over quite a distance, and that gives us time to be able to also intercept the people.
You have a day-night capability, you have good record keeping, you could go back and analyze what has happened, and you have the ability to direct your forces. Whether it's a border or a boundary or a perimeter, we talk about a perimeter. And a perimeter you do in layers. You talk outside the perimeter, on the perimeter, and then the various layers inside your perimeter. You've got to be able to observe, to sense, to get early warning, to detect, and to track. And that is what the system allows you.
So we've developed the system at a record pace to try and get the system in the park as soon as possible. And the system went operational just over a week ago. And within the first day, the first poacher was caught. And since then, we've observed 3 more poaching teams. The system consists of a radar and a long-range electro-optic system. And the 2 sensors complement each other very well. The way that the system works is we utilize the radar to observe all the motion, and then we cue the electro-optics to help us to identify whether that is an animal or a person. In both anti-poaching operations and border safeguarding operations, the suspects often operate at night. So it's very important also to look at a day capability as well as a long-range night capability. What happens is when we identify a track and we look at the nature and how the track is moving, we decide it's something which is worth investigating. Then we scan the camera there and we utilize the laser to illuminate that area. The laser is near infrared so that the person cannot see that he's being illuminated, but the low light CCD camera then picks up that, and then we can identify the person either as person or animal. Obviously we need to utilize the system in conjunction with the local reaction forces, and that's the local ranger unit. Where the local ranger is stationed is not necessarily the best place for observation. So the first aspect of the system is it is a remote system. The system operates completely autonomously. For example, over here we are deployed 20 kilometers away from where we sit is where the actual system is, overlooking the area of interest. And the operators sit over here close to the reaction forces, and they are doing the observation, and then when they pick something up, then we can interact with the reaction forces and they can appropriately respond. So the best vantage point for the system is on high ground, typically mountains, which are difficult to access. So the system has been designed to be mobile. So the system gets driven close to the mountain on a pickup truck, and we unload it, and then we airlift it to the top of the mountain, and we set it up from there and set up a comms link to be able to operate the system 20 kilometers away. Here's an example of a track which is caused by an elephant. And again, we have used the electro-optics to identify whether that's an animal or a person. And that's the primary goal. The thing is, if you start searching with electro-optics, it's a very operator-intensive thing, especially if you have to start scanning the electro-optics. But the radar is accurate enough that we position the optics so that the thing that has moved is in the field of view, so it's very easy for the operator to see it.
The Meerkat system is the result of a joint development program that utilizes the strengths of Vertec radar systems and the CSIR. Together, the organizations have developed and delivered various systems to operational end users. The longer-term goal is to further co-develop automatic classification capabilities of the Meerkat system, as well as various other systems that will be relevant to land surveillance and border protection.
It's a force multiplier of note. You cannot go force and force. You cannot in this vast bush just go and chase poachers. You've got to do it, but send your resources to the right place at the right time, because you know where they are and you can be cost effective.